Hello everyone, welcome back to our channel. In today's video, we are going to tackle a classic LeetCode problem called Palindrome Linked List. This problem is fantastic for testing your skills in linked list manipulation and algorithmic thinking. Understanding how to identify a palindrome in a linked list is crucial for your coding interviews, as it tests your ability to work with pointers and manage linked list structures efficiently. So let's dive in and solve this problem step by step. The task is to determine if a singly linked list is a palindrome or not. So you'll be provided with a linked list and we'll have to check whether the linked list is a palindrome or not. So if you look at the problem statement, it says that given the head of a linked list, return true if it is a palindrome or false otherwise. And a palindrome reads the same forwards and backwards. So for example here, if you'll read from forward, then it is 1. And if you read from backward, then it is 1, right? And if you move ahead and read towards forward, it is 2, and when you read towards backward, it is 2, right? So here the values are matching. 1 is matching with 1, and when you move forward and backward, then 2 is matching with 2. So finally we can say that this is a palindrome, because a palindrome reads the same forwards and backwards. So our goal is to check if the linked list elements are the same from the start to end and end to start. Okay. For example, in the second one, you can see that the first element and the last element doesn't match, right? So that's why it is not a palindrome and will return false. Okay. Let's look at the approach. So there are many ways to solve this problem. One way would be by making use of stacks and storing first half of the linked list and comparing with it the second half. And another way is to store all the values of the linked list in a list and then use our traditional approach to detect whether it is a palindrome or not. And the third and the most optimized approach is by dividing this linked list into two halves and then reversing the second half and then finally comparing it with the first half. Okay, so this is our optimized approach. So in our optimized strategy, we'll find the middle node by using two pointer technique, and then we'll reverse the second half, okay, and then finally compare it with the first half. Okay, so let's walk through this approach with this example. So initially, to find a middle node, we'll use a two pointer technique, or the famous Floyd's fast and slow pointer technique. Okay, so to do this, we'll be needing one slow pointer and we'll be needing one fast pointer. So two pointer technique suggests that slow pointer will move with one step ahead and fast pointer will move twice the speed of slow pointer. Initially, both slow pointer and fast pointer will be pointing to the head of the linked list, and slow pointer in each iteration will move with one step, but fast pointer will move twice the speed of slow pointer. So in second iteration, it will move here and fast pointer will move here. Okay, and again slow pointer will move here in next iteration and fast pointer will move twice the speed and it will reach null, and that's where we know that we'll have to end. And at the end of this iteration, we'll find that our slow pointer is pointing to the middle of the linked list. Okay, so now after dividing this linked list into two halves, okay, and finding the middle node, that is 6, this is our middle node. Now what we will do is we will reverse this linked list. Okay, now to reverse this linked list, we'll have a pre pointer, and this pre pointer will be pointing to null. We will also have a current pointer, and this current pointer would be pointing to the mid element. And we'll reverse the linked list one by one by making use of this pre and current pointer. In each iteration, we'll disconnect this link and make it point to the previous node in this way. And then we'll update our pointer in this way. So this current pointer will point to the point here, and this pre pointer will point to here, point to this. Similarly, in second iteration, the next pointer of this will point to the pre pointer in this way. And then we'll update our current pointer to point to this, and our previous pointer will be pointing here. Going ahead, this 4 will now point to 5, and our pointers will be pointing in this way. And finally, we'll return this pre pointer, which will be the last node. Okay. So at this point of time, we have a pointer called P2, which is our last node, and obviously we have our P1 that will be pointing to the head of the linked list. At last, what we'll do is we'll use these two pointers P1 and P2 to traverse both halves. We'll compare each node of the first half with each node of the second half, and at any point of time, if it doesn't match, then we'll return false. And at the end, if everything is matching, that means it is a palindrome and we'll return true. Okay. So here, if you see, initially P1 and P2 would be compared, and it sees that both the values are same. So it will move forward like this, and it will move forward like this. So now also it will see both the values are same. So again it will move forward like this, and again this will also move forward like this. Finally, it sees that all the values are matching. So that's why it will return true. So when all the values match, the list is a palindrome, otherwise it is not. This is the core logic. Now talking about the time complexity, the operation of finding the middle, reversing the second half, and comparing the two halves are all linear in terms of the number of nodes in the list. That is, first time when we are trying to find a middle node, then we had traversed once. So this is linear in time. So it will take O of n, right? So second, when we try to reverse, it is also linear time, right? So it will just traverse through half of the nodes. So this is also O of n. And finally, comparing from this side to this side, first half and second half, this is also linear time. So since each of these operations is performed sequentially and each takes O of n time, the time complexity is O of n. Also, we only use constant amount of extra space for pointers and variables. Therefore, the space complexity is O of 1. So that is the overall approach to solve the problem. Now let's dive into the code. Before moving forward, let's handle some edge case, like if there are no values in a linked list. Okay. So when head is none, or if there is only one value in the linked list, that is head.next is none. If there is no value in a linked list, then it is automatically a palindrome, and if there is only one value, then that will also be considered as a palindrome. So in that case, we'll return true. Otherwise, as we have discussed in our approach, that our logic will be divided into three main parts, right? So that is finding the middle node, and then reversing the second half, and finally comparing the two halves. So to find the middle node, what we'll do is we'll have two pointers, slope pointer and fast pointer, pointing to the head node, and we'll run a loop until fast pointer and fast pointer is not pointing to none, and fast pointer dot next is also not pointing to none, and slope pointer moves with one step ahead, but fast pointer moves with twice the speed of slope pointer, that is 2 steps ahead. Now at this point of time, we know that slope pointer would be pointing to the middle node. So now we'll reverse the second half. Okay. So we'll reverse the second half, and after reversing, we'll get our last pointer. So we'll denote it P2. So P2 will reverse. We'll write a function for this, saying that reverse linked list, and we'll pass a parameter of the mid node, that is slope pointer. Let's define this function first. So define reverse linked list. So it will take a head of the linked list, and the logic to reverse a linked list would be like this. We'll have a prev node pointing to none, and we'll have a current node pointing to the head. Now we'll run a loop until and unless current dot next is until and unless we have current dot next, that is current dot next is not none. Okay, so we'll iterate till the last node, and here what we'll do, will in each iteration we'll keep a temporary node called next node, which will be currents next. We're doing this because since we'll update the pointer of the current next, so this information would get lost to update. That's why we're doing that. And finally we'll update our pointer. So current dot next will not be pointing to its next now, it will be instead pointing to the prev node. And finally we'll update our nodes as well. So now after making the changes, after shifting the next pointer, our prev will be updated to current, and our current will be updated to the next node. Okay, at the end this current would be pointing to the end node, and we'll also have to update its next pointer because that is left. That's why current dot next would be finally pointing to our updated prev value. So in each iteration prev will be always behind cursor, and at last we'll again do this, perform this. That's 4 was pointing to null, it will now point to 5. Okay. And finally we'll return our current node because this is the end of the node. So after performing this will be reversed, and this p2 will be pointing here. So finally we have returned cursor, and we have stored this value in our p2. Okay, so p2 is self dot reverse linked list, and the head of the second half of the linked list was our mid pointer, that was the slow pointer. Now finally in the third step we'll compare the two halves. To compare two halves, as we discussed, we need two pointers, that is p2 and p1 pointing to the head of the linked list. So we'll define p1 as head of the linked list, and then finally we'll run a loop until and unless we have p2. That is, we'll run a loop till it reaches here, this null. Okay, so we'll compare p1 and p2, and p1 will move forward, p2 will move backward. So we'll do this till the half, okay, till the boundary. So while p2, what we'll do is in each iteration we'll check whether the p1 value matches with the p2 value or not. If it doesn't match, then that means it will not be a palindrome, and we can simply return as false, saying that the value doesn't match, so it will be false. But if matches, then we'll return true at the end. Okay. So what we're doing here is, if at any point of time if it doesn't match, then it will not be a palindrome, and we'll update our pointer value. So it will move forward, and p2 will also move backward. Okay. So in each iteration these will move from here to here, and these will move from here to here, and it will, in next iteration it will go here and it will go here. Okay, that's what we are doing here. And finally at the end, if all the values are matching, then we can say that it is a palindrome, and we'll return true. Now let's run this code. Cool. Let's submit this code. Awesome. And that's how we solve the LeetCode problem, palindrome linked list. By dividing the list, reversing the second half, and comparing both halves, we efficiently determine if the linked list is a palindrome or not. This method is great for coding interviews as it demonstrates your understanding of linked list operations and optimization techniques. If you found this video helpful, please hit the like button and subscribe to our channel XStep Pro for more coding challenges and interview tips. And don't forget to click the bell icon to get notified when we upload a new content. If you have any doubts or suggestions, feel free to leave a comment below. I'd be more than happy to assist. Thanks for watching, and I'll see you in the next video.